Welcome back to Chapter 3, the last chapter in Exam 1 material here. Um, where we left off last was an introduction into acid-base chemistry, and you may have noticed me doing something that we had never done before in this course, and that is using arrows to talk about electron movement and making bonds. Because in that last section, I did something like this, where we had, say, hydroxide. We'll say it was sodium hydroxide, and maybe we add in a really strong acid like HCl. And in that example, this is a paraphrasing of that example, I used arrows to show what happened mechanistically to cause a reaction to occur. And that reaction is shown here. This is something that we have not done in this course because now is when we're starting to learn it. This is our very first foray into mechanisms of organic chemistry, and lucky for us, it comes pretty early on in Chapter 3. It's not such a difficult concept, especially when you consider that we already have a little bit of knowledge with curved arrows from our work with resonance and resonance structures. So in general, this is called curved arrow notation for showing reaction mechanisms, and that's what section 3.2 covers. Now, your book doesn't go into this very much, but we certainly will now and for the rest of the course. Actually, you'll do this now for like the rest of your whole career in chemistry, looking at these curved arrow notations and using them to talk about reactions and how they occur. So it's very easy to use curved arrows. All you have to do is remember that curved arrows start from an electron, or for instance, let's say we're using some kind of carbon. Let's say we're using this carbon just for an example, or the example can be a double bonded carbon. Okay, when you use these arrows, they have to start at either a bond or a lone pair. And assuming there's something to react with, like say, say a proton from water, then the arrow will start at a lone pair and the head will point to the atom that the lone pair is taking. And this, or the lone pair is moving towards or attacking. In this case, for acid-base reactions, that is a proton, a hydrogen. Hydrogens in acid-base reactions are called protons because they are simply just a proton. They don't keep their electron. In fact, those electrons stay with the atom that was attached to give products of the reaction. In this case, now we have methane plus OH minus. A couple things to note about this. You see how the change in proton, which atom is attached to the proton, is shown here in this drawing with color. But also notice that in the beginning, our reactants, one of them had a negative charge, and the product also has a negative charge. It's called conservation of charge, and it's very important when you're writing reactions in organic chemistry. And then the last thing to note is that the electrons that were bonding this oxygen and hydrogen in the acid, they are retained onto the oxygen atom. So in another type of acid-base reaction, the base can instead be a bond. And if the base is a bond, and you have, say, some other type of chemical like this one, then in that case, the bond electrons or where the arrow starts, and they end once more at the proton. And those electrons from the, in this case, hydrogen bromide bond, go right back onto the bromine atom to give you, in this case, one of these H's should be blue. Plus Br minus. So we don't have to go into the specific reactions now. These are just examples of how to use curved arrow notation. So remember, arrows start at lone pairs or bonds, and they end for acid-base reactions at the proton. And this has been section 3.2.